So in the last class, we had discussed about the course outline and what is all about big data, right? So can anybody tell me what is big data? Anyone who can tell me what is big data? Yes, please. What is big data? But you have to be interactive. You have to respond whatever you are thinking of. You can come out with your answer. I'm not looking for
Ma'am,
any definition. I just want to know your understanding. That's it.
ma'am, large
Basically
volume of complex
database.
data.
Yeah, large volume of data.
Yeah, basically large volume of data with which has a lot of variety.
Correct.
And
Anything
it is
else?
fast. Ma'am, it is fast.
And it is
Fast.
okay. That is the inherent complexity of the data. And what else? See, when we say that we have a large variety of data and we have huge volume of data, 95% you are correct, but there is something left that is to be
Like we have
considered.
three main major V's: variety,
Yeah,
velocity, and volume.
right, right. So these are basically the three factors, you can say these are the three parameters which determine that whether the data that we are talking about that is big data or not, right? So in the last class we discussed that when we say we have huge volume of data, right? But when we have huge volume of data at one point of time, see, we can make the arrangements. Let's say we have 1 terabyte of data or 1 zettabytes of data, and we make the arrangement and accordingly, like we have purchased the storage or we have borrowed the storage on rent, or we have started working with that particular data. But since we are able to handle that even zettabyte of data at one point of time, and we are able to work, so that means it is no more big data because we are able to handle that. But the thing is, see, it may also be having the variety of data. You can say the data may be text, pictures, your images, or the videos. But the thing is, the important factor that determines that this data is big data or not, that is the rate of growth. What is the rate of growth of this data? That means the speed with which the data is growing. See, if the data is stagnated, that means once, let us say you created a portal and 1 billion users have already registered, and you are not allowing any more users to register over there. So this is a fixed set of users that you have to deal with. But in the real time, we say in the Facebook, on the Twitter, on the Instagram, so many social media sites are there. There we see every day billions of users are joining, right? So that means there is a rate of growth, right? If the rate of growth is like this, that you can say there is some data that maybe, let us say, if we are talking about the data from the NASA, or data from the Facebook, or data from the eBay. So where, how, with the speed with which the data is growing, if we are adding 1 million users every week, every month, every year, or it is being, you can say, these number of records, they are growing every second, every minute, right? So we can understand the dearth of that particular data, the amount of data that is growing, if we say the rate of growth is per minute or per second, or it is per week, per month, or per year. If it is per year, then we can handle it. There is no problem in that. Then we say that it is not a big data. But yes, if it is per minute, per second, per week, the number of users are every week, millions of users are growing. That means we need to handle this growth of data. So then we say we have big data. So when we are defining the big data, we just not only focus on the volume of the data, but we should also focus on the rate of growth of the data along with the variety of data that we have to deal with. So this is how we define when we are talking about big data. And big data is never, you can say, precise term. It is always relative. So the data, like there was a time when 1 GB was big, then one TB was big, but now we are talking about petabytes and zettabytes. And then after some time, we may be having some more terms in order to define that particular data, right? So how to quantify that data? We are always talking in relative terms that we are going to deal with. So if there is some data and somebody is trying to know whether this is a big data problem or not, you have to understand whether it involves large variety or what is the rate of growth. Even if the volume is big, if the rate of growth is low, then we say it is not a big data problem, right? So this is how we have to handle the problems when we are dealing with big data. So this is all we had discussed in the last class, right? So the rate of growth everywhere we see how the number of tweets, you can say to 12 plus terabytes of tweets data every day it is being generated, right? You can see there is one picture from the Domo that shows what's happening in every 1 minute. So you'll understand what is the rate of growth, or you can say the speed with which the data is being added, or the speed with which data is growing for Google, Facebook, Twitter, or you can say the Amazon, the number of deliveries. Then we have large number of portals, you may be knowing more names than me, where we are saying that we have large amount of data that is being growing, right? So now in order to see, some people also make it 4 V's. That is, the fourth V is veracity, that is data in doubt. That means, see, billions of dollars are being spent by the US in order to handle the veracity of the data. That is because the data that we receive, that is highly inconsistent and incomplete, and there are a lot of ambiguities which are there in these particular data. So in order to handle this particular data, or you can say, see, whether we say internet is the most, right, untrustworthy source of data. So we cannot trust the data that we have received from the internet, right? So we have to understand that particular data so that we are able to say, you must have heard of GIGO, garbage in, garbage out. If you have dirty data, if you don't have the trustworthy data, see, if you're going to give the garbage, whatever algorithms, the best algorithms you apply over there on that particular data, if the data is dirty, if the data is not trustworthy, you are not going to get any good results. So that means it is going to be like garbage in and garbage out. So whatever best algorithms you are able to apply. So that is not going to give you any information. It is not going to help you design any of the business policies. It is not going to help you in any way. So that is the fourth way that is being added, and a lot of money is being spent by the various organizations who are dealing with the data analytics, because majority of the organizations these days are performing the data analysis, and they have to deal with the various inconsistencies and the incompleteness, that is the ambiguities which are associated with the data. When we say, see, how do we, what was the, if we see the history, or if we see the evolutionary process, how people have been utilizing the data. So it started in the 1970s, let's say, or 1960s, when there were hierarchical databases, or the people were working with the DBMS. And that time we had only the online transaction processing systems. So the online transactions, you know about the DBMS packages, that like your MS Access or Oracle or MySQL or SQL Server, all these are transaction processing systems. So these were only the operational databases, and after that, lot many people were working on this data, the transactional data that was received, and creating the reports out of that. If you have studied the report in the MS Access, also you have option to create the reports like sales reports or the employee performance report, and such kind of work was being done, but that was the you can say the manual work that was being done. And we say that was the data at rest. So there was no change in the disk. Once the data is stored, there were no updations, and whenever we are going to get more data, after that we will be doing the processing or the analysis of that particular data. Then in the later, then in say in the 1990s, then came the concept of data warehousing. So what we were doing is, in the data warehousing, online analytical processing system, right? So in online analytical processing system, the weekly data was stored in the data centers, and there the analysis was performed on the current data to improve the business transactions. So, but still, see, if we see the speed with which the data is growing, in that speed, we cannot wait the business processes, they cannot wait even for the minutes or the hours. Then if the data is being analyzed, let us say after a week, and the decisions may be taken within a month, that means we have lost the opportunity to handle the request, or you can say to handle the business. So that means the opportunities which were there a month ago, now they are no more available after the month when we are trying to take the decision on the 1 month obsolete data. So then came in order to handle such kind of problems, right? Then came the era of the stream computing that we say since 2000 onwards. So we are talking about data in motion, or you can say we are performing the real-time analytic processing in order to improve the business response. See, everything, whatever data we are processing, whatever analytics are being performed, they are meant for improving the business only, in order to increase the profits only. So the main goal behind that is increasing the profits of the business. So the real-time analytical processing system is that if you are, so let us say I'm the customer and I am going in the mall, and that time only I should get the promotions that we are getting getting these days. If I'm choosing some product, immediately, like all time when we are making the shopping online, we are being tracked. So all our activities, whether we are navigating through the web pages, whether we are clicking on certain products, everything is being tracked, and based on that we are getting the recommendations these days from the various you can say e-commerce portals. So this is how we say we are talking about, we are dealing with. Now, in order to give a response in the real time, that is one of the biggest challenging tasks, because we are dealing with billions and billions of users. Now, how can we process the data of billions of users and analyze their requirements, and then understand their, you're gonna provide them the personalized recommendations, which is being done by large number of, you can say, the e-commerce portals or the big organizations, right? How this is being done. So in order to see, we will see what are the issues, what are the challenges when the companies have to harness the big data. Then like how do they do that? So in order to provide the real-time analytics, or in order to avail the opportunities, the businesses, they are acquiring the, you can say, they have to take the best hardware, they have to take the best storage facilities, best processing computational units. So everything they have to take the best, so that they are able to reduce the real-time analytical processing time. So now we are going to discuss about all these things only. So because as I said, the real-time or the fast data that is coming, we know about that, the social media networks, scientific instruments, mobile devices, this is the data that is being collected, and that is at a very fast pace they are collecting. So now in the current scenario, the problem is no longer, you can say, the progress and innovation, it is no longer hindered by the ability to collect data, but by the ability to how to manage, analyze, summarize, visualize, and discover the knowledge from the data that is being collected. And that too, we are able to perform this task in a timely manner and a scalable fashion. So because we are talking about dealing with millions and billions of customers. Right. So if we see the various the task that we have discussed just now, so if you can say the traditional approaches that we have seen, the OLTP, OLAP, and the real-time analytical processing. So if we talk about OLAP and OLTP, we used to perform the ETL on the data. So what, as I said, when we are talking about data warehousing, we are performing the ETL task over there: extract, transform, and load the data. And then see, when we have taken the weekly data, so the whole transaction data is not stored in the data warehouses, only the summaries of the data. So the denormalized, summarize the data and denormalize the data, and then the results of the such data are stored in the data warehouses. But when we are talking about summaries, that means we are definitely discarding certain details. So when we run the queries against the summary data, that means all the queries, all the analytics we do. See, when we are doing certain kind of analysis, that means we are writing, see, what were the sales of a particular product in a particular zone. So this is one query that we are going to run on the summary data, and then we are going to get the answer for that. So this is how we do why, when, right, and how much. So these are the analysis we perform on the existing data. But when we are performing all these queries on the summary data, that means we are going to lose certain details. And if we are, let us say, if we are going to take the summary of 1000 rows or 10,000 rows or 1 lakh rows in a single record, we can definitely understand that we are definitely losing the details of the data, and we cannot summarize 1000 or 10,000 rows in a single record. So we say that more data means deeper understanding. If we are able to deal with the data, right, and we are able to store the complete data, and rather than analyzing the summary of the data, we analyze the complete data. In that case, we may be getting we'll be able to get the better output. So better results we will be getting. So according to the Murray, there is no data like more data, and we say that it's not who has the best algorithm that wins. It is the one who has most data. So in the current scenario, we say data is the new enterprise currency. So it is considered equivalent to the currency. The data is considered equivalent to the currency in the current scenario. Who is having the more data? He is the richest man in the world. So let us understand one big data problem, right? So that the challenges which are there in handling the data, in handling one of the analytical problem. So what are the issues associated when we say that we cannot deal with the big data with the existing tools and technologies which are available. So let us say you are given an assignment. We know there is a lot of data in the stock market. So stock data set by day stock information for all the registered companies. Let us say we have the all the most of the companies, they are in the registered in the stocks, and you have the complete stock data available with you. Now we have a one let us say we have a one stockbroker who wants to deal with this particular data, and the size of the data is 1 terabyte, and the problem that he wants to solve is that he wants to find the maximum closing price of each stock. Let us say now, since he is having 1 terabyte of data, and he is not he comes to you and tells you to solve this particular problem, right? Now how will you handle this particular problem? Can anybody tell me? If you have the data that is whose size is 1 terabyte, now if you have to perform this particular query, find the maximum closing price for each stock, right? And you have 1 terabyte data, then you can understand how many tuples are there in that particular data. Let us say you have, and about the stock, you know how many columns are there, maybe 5-10 columns are there, but the number of tuples are very high. So can anybody tell me that how are you going to resolve this particular problem? Yes, please. Anyone? So you can tell me the challenge which is there. Okay. Don't give me the solution. You tell me what is the challenge.
Handling large amount of data is the challenge
The
here.
challenge is to how where to store 1 terabyte of data, right?
Yes,
Then
ma'am.
next challenge is one is storage, let us say, right? So one challenge is the storage, right? And second challenge is will be computation. Agree?
Yes, ma'am.
See, one challenge is storage, how to store this particular data. Let us say now we have the capacity of only 20 GB, and we tell our server room people, let us say we are in JIT, and we tell our server room people that you give us some storage on the server, and we are able to get that storage, and we are able to store this particular data. Now we are sitting on our system, and now we have to fetch the data from the server, right? Right. So now the challenge, another challenge will be how to compute, right? So the computation. So dealing with this particular data, then how much time it is. Let us we have arranged for the storage on the server, and then we can do the computation also. Now what will be the data access rate? Can anybody tell me? Let us say we have to compute the execution time, because we have to answer this to our client that for processing this particular query on this much of data, how much time will require so that we can answer we can perform this particular task, right? So we have arranged for the data storage from our server room. Now, what is the execution time that will be required? So the execution time that is required, see, when you, let us say you have written one program on the database, right? You have used the JDBC or any other database access, right? So how do you define the amount of which part takes the more time? If you have written a program that read data from the database, the maximum amount of time is spent on what? Yes, please.
Ma'am, computing.
Computing, and plus how much time is spent on the accessing the data from the storage, from the database?
So, ma'am, the data that is stored in the database depends upon the type of structure that we are using to store the database. Let's say we can use
Let us say,
like what's being used in the backend to store the data.
okay, just give me one example and accordingly we will proceed further. Like,
Ma'am, I don't know whether it's correct or not, but according to my limited knowledge, I feel that we
yeah,
can use heaps. Let's say a heap to, let's say a heap. Like if we have to find the maximum stock price, the problem is to find the
let
maximum
us say,
stock.
see, we are talking about 1 terabyte data, so that means we require some DBMS.
Yeah, so the internal
Yeah,
structure of
some,
the DBMS, the file
yeah, yeah,
system is
right,
actually
right, right,
on based on some data structure
right,
itself.
right, right,
Like
right. That
we
is
use
fine.
BNB, like let's say tree, BOB
Yeah,
plus trees in a
yeah,
file
yeah, yeah.
structure to store the
Okay,
data,
yeah,
like to index and then store. So
right, right. But still the data, let us say the data is stored on the hard disk only. That
uh,
it is, see, it's store the DBMS. If when we are talking about the persistent storage, right, we will have to read the data from the persistent storage to the RAM for the computation,
yeah, so ma'am, in the
right?
RAM also
See,
the file system
just a
gets
minute.
the data
Yeah,
from the hard disk only.
yeah, yeah,
So
yeah.
in the hard disk, it's not stored like it's basically
It is
indexed
reading.
and
Yeah,
stored.
yeah, yeah, yeah,
And
yeah.
then
That's
there is
what
a
I'm talking.
structure that's used to store that data.
Right, right. So that means if we consider that we have to read the 1 terabyte of data, then how much time it will be taken by the hard disk to read the data?
I don't know, like maybe
Okay.
if we use
Yeah,
heap, it
yeah,
could be login sort of
yeah,
something.
yeah, yeah. So, so for, let us say, you can say the for on an average data access rate for a hard disk is 122 MB per second. This is considered to be, you can say, as per the studies, the average data access rate of the hard disk is 122 MB per second, reading ability of the hard disk, right? So for 1 TB, for reading the data that is of size 1 TB, it's going to take approximately, we are saying, 2.5 hours to read from the disk, right? And now let us say for processing that particular query, the query is to find out the maximum price for every stock. So it takes approximately 1 hour, right? Along with the you can say, depending upon the network bandwidth that we have. So we can say that if we consider this much of time that is required, so the total execution time that is required is approximately near around 3 hours, right? So we are just making a guess that if it is on an average, your hard disk takes 122 MB per second, and for TB data, it will require 2.5 hours, and near to 1 minute, near to 1 hour we require for the computation. Then the total time it requires for the approximately 3 hours. Now, if we are talking about 3 hours and you tell your client for executing one single query on this particular data, you require 3 hours, the client will never like it, right? Because if he has to execute this particular query, because the stock prices, you know how the prices of the stocks change after every few minutes or few seconds. So if the person is involved, his finances are involved into this particular business, he may have to bear lots of losses if this particular query takes this much of time. So he asks you to reduce this particular time of 3 hours. Can you reduce this particular time of 3 hours, maybe 30 minutes, or sometime, let us say, near to 1 hour? So what is the, you can say, the challenge, right? So this is what we are trying to understand when we have to deal with big data, what kind of challenges we come across. So one of the challenges is the storage of the data, and another is the computation time, because it takes with the existing resources that we have, with the existing infrastructure, it is going to take this much of time. Now, in order to reduce this particular time, what are the options? So let us say, since we have identified that we have two main tasks, one is storage and another is computation. Now, for storage, can we replace hard disk with something else? What is available in the recent, these days, new technology that is available? Instead of hard disk, what can we use? SSD. Now, you know what is SSD is available, right? So what is the cost of SSD? It is 5 to 6 times more than the hard disk, right? So that means we can replace HDD with the SSD, but it is very expensive, so we cannot bear that expense. We have to find out some better solution where we don't have to increase the cost also, right? So what do? So let us find another solution with the existing infrastructure only. We are going to use the hard disk. But what do? We split 1 terabyte file into 100 equal sized blocks and read them parallelly. Do you think it is going to help us, or it is going to create some new problem?
It will help us, ma'am.
It will help us. Okay, so we can, by applying this new strategy, what do? We are able to reduce the time to read, because 150 minutes divided by 100, we are able to reach to around 2 minutes. And we are also able to reduce the computation time from 60 minutes to approximately 1 minute, right? So do you think there is some challenge still left, or we are able to resolve the problem? We have reduced the time to approximately 3 minutes, from 3 hours to 3
But
minutes.
ma'am, for every we'll have to read for each of those 100 blocks, na? It's just like for one block, it's less than 2 minutes. For let's say we have 100 blocks, we'll have to go to each 100 block to get the maximum stock price or whatever
Yes.
query we are getting. So it will won't it be approximately to 150 minutes or for
See,
each block?
right. See, it's not going to be this problem, because see, one problem we are going to face is, because it is not going to be absolutely parallel. We are talking about parallel processing over here. When we have divided the 1 TB data into 100 equal size blocks, then we are saying that we are trying to read them parallelly. One thing is, it's not absolutely parallelly, but the problem that we will arise is the bandwidth, because we are reading the data from the network, from the server. We are trying to read the data, and we have the same hard disk which is reading the data. It is like you have one internet connection at your home, right? You have one internet connection, and all the members, let us say you have 20 members in your family, and all are streaming through the same internet connection. So what will happen? What will be the output each one will be getting from the same internet connection and having a fixed bandwidth?
So ma'am, again, the data rate would be low.
Yes, that is the problem.
The
So
rate
that
of
means,
reading the data would be low because the bandwidth is not available to read that
actually,
data.
right? So that means the streaming, like you can imagine that the old system of streaming the videos, right? Sometimes if you have seen the Hotstar is not having very good streaming API. So when you are, maybe when it is through, let's say, Tata Sky or something, if you see certain video streaming APIs, some streaming this thing channels, so in that case you'll see how it is streaming slowly, that kind of experience. That means nobody is able to enjoy that, right? So similar kind of experience you can understand over here, you will be getting. So when we are trying to resolve one problem, we are going to face another challenge, right? So here the new challenge that we have come is bandwidth problem, right? So we resolved one problem, but now with the new problem, you can say with the new solution, there is associated another one more problem. So in order to handle the such kind of problems, so what we can do? So since it was the bandwidth problem, so because we had to read the data from a different server, what we can do is we can bring the storage close to the computation, right? So the only solution that we can have is once we have divided the 1 terabyte data into the multiple blocks, like into the 100 blocks, or then rather than bringing the data from you can say the far storage which is at a far off place, or you can say it is on another server, isn't it better that we read that particular block of data from the local storage only? So because now since size of the data is being reduced and that is affordable, we have that much of space. See, 1 terabyte space was not space for storing the 1 terabyte data was not available, but yes, 1/100th part we can handle that particular data on our local system also. So rather than, so in order to reduce this problem, in order to handle the problem of the bandwidth, what do? We bring the storage close to the computation, and then we are able to resolve this particular problem. So here you can say that the problem that was there when there was a big data problem, which could not be handled with the existing infrastructure, the existing technologies, that can be handled with a new way of performing the data. And this is also, but the challenge over here is, one challenge is who will do the division. We say that split the data, 1 terabyte data, into 100 blocks or 50 blocks, whatever is required. But who will perform this particular task and how it will be performed? Again, it is a challenge, right? How, in what way we should create the blocks, right? Then who will, besides that, another challenge is, since we are, in order to solve the problem of the bandwidth, we are storing that data, that block of data into our local system, then there is a problem of data loss if this node fails, this particular system. If our system, we all have faced the problem of system crashes. If our laptop crashes, we are not left with any of the data. That's why we say, what if some data is important to you, you keep it in the drives. That is the option that we have. But here, how to resolve this particular problem? So in order to resolve this particular problem, the only solution that we have is the replication of the data. Replication means create the multiple copies of this particular data. If we have, let us say we have, here you can see we have written block 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us say we have created certain blocks. So rather than storing block 1 only on the one node, we create 2 more copies of this particular block and keep these block copies on the node to node 3, or depending upon the number of nodes we have. So we create the desired number of copies, and the number of copies also we cannot keep on creating unnecessarily. So the replication factor that is considered best for the storage of data, that is considered as 3. So that means at max you should create only the 3 copies of your data, and if you can lose 3 copies of the data, that means anything can happen in this world, you need not worry about that, right? So 3 is the maximum number of that is the replication size that we have to you can say considered as a standard way of replicating the data. Now, in order to handle this particular kind of problem, let us say, who will now again we say that the replication of data we need to, in order to handle the loss of data, who will do that replication, right? So in order to see, in order to deal with such kind of problems, which can be handled with the existing infrastructure only, but by applying the different, you can say the different intelligent strategies, basically, these are the different tactics that have been considered, that we are using the existing commodity hardware only, but by using the different strategies, we are able to solve the big data problem. Now, in order to handle this particular problem, that who will create the blocks, who and how these blocks can be created, who will be creating the replicas, and handling of all these things can be done automatically with the help of one, you can say, framework that is called as Hadoop, right? So this is the work that we say, what is the need of the Hadoop, and what is the purpose of using Hadoop. You can say this is the purpose of using Hadoop, that all these tasks that we are discussing, who will do this particular task, this is being done by the Hadoop automatically. So So in order to handle this particular problem, what we need a system that scales. So we are generating since too much of data with the traditional tools, and we have too much to process. So the two main problems that we need to address is how can we reliably store large amount of data at a reasonable cost. As we have seen, we can store the data at a reasonable cost. So as we have seen, by splitting the 1 TB of data into, let us say, the 100 blocks, by splitting the data into 100 blocks, we are able to store this particular data, right, at a reasonable cost. But we have to make it reliable. And then how can we analyze all the data that we have stored? That is the computation part. How can we do that so that our cost is also not increased? So Hadoop provides a solution to such kind of a problems that we are facing when we are handling the big data. So it supports huge volume. Storage efficiency is very high for when we are working with the Hadoop. Good data recovery solution, because we are creating the replicas. The replicas are created automatically by the Hadoop. And then, so that means if one block which is available, let us say one part of, let us say the 1 to 10 rows, they are stored in the node 1. Then if this node fails, in that case, the same block of data is also available on 2 other nodes, right? So if some query, somebody has fired some query, and in between this node has failed, automatically the query will be diverted to the another system which is still active, and the user will not be facing any kind of issues, right? And whenever that node starts working again, it will take over the work. Horizontal scaling. So when we are dealing with the RDBMS, and the major problem that we have to face is after a certain limit, see, we can store the data in these existing RDBMS up to a certain limit. After that, you can say, if let us say you have a laptop, and now I want you require, see, we have to for working on the Hadoop, you require a cloud data framework. For installing the cloud data framework, you require 8 GB RAM, minimum 8 GB RAM, otherwise you won't be able to work on that. So now let us say you have a laptop with 4 GB, and whenever you buy any of the laptops or any of the personal computers, you know the limit which can be supported, right? You can extend the RAM to up to a certain limit, you can extend the hard disk to a certain limit. So beyond that, you will have to take the new motherboard. That means the complete new system you will have to buy, right? So this is, we say, the horizontal scaling. So you can increase the RAM from 4 GB to 8 GB, or let us say 8 GB to 16 GB. Beyond that, you cannot increase the RAM because that is not supported by your hardware. So this is called as the vertical scaling of your system. So beyond that, you cannot handle that. Your system cannot handle. You will have to let us say, so this is the hardware limit of your system. And along with that, see, if let us say you have, let us say, as one of you said, that within the software also, in the DBMS also, you may be applying various efficient techniques. You may go for the query optimization. You may go for the various storage efficiency techniques, the algorithms which we have, the various indexing techniques we may improve. But all these are going to have a certain limit. And beyond that, you will have to, you can say, we'll have to invest in the expensive infrastructure in order to handle the various problems that you are facing. But in case of Hadoop, it is based on horizontal scaling. So horizontal scaling means, let us say you have one laptop, right? So you are able to handle the problem. Now, if something else is required, if your requirements are increasing, you just buy another similar laptop and you are able to handle that. So let us say one laptop is one node and another laptop is another node. So you can keep on adding as many nodes as possible. So horizontal scaling is supported by Hadoop. And see, these are, here you can say, these are the inexpensive hardwares that we are going to add, with which are, you can say, you can say cheaper as compared to the servers that we have to purchase or which we use in case of the existing infrastructure, right, which was required for handling the big size of the data. So that's why this is the reason that it is cost effective, because we are working with an inexpensive commodity systems, so the commodity softwares or hardwares. And it is also easy for programmers and non-programmers to work with the Hadoop. So that's why we say, in order to handle the various problems, the various challenges which we have seen when we are dealing with the traditional tools, the Hadoop provides us a good solution for solving all such kind of problems. So when we compare the Hadoop with the RDBMS, we say that Hadoop provides a dynamic schema. We don't have actually any schema over there. We are working with the file systems. We will get into the details of that in the next class. And here we say RDBMS, whenever it is based on the, you can say the creation of the tables, where we have to design the schema, and this schema is static. We have to make a complete, we have to completely update the schema or change the schema if there is a small change in the input that we have received. Excuse me. So it is linearly scalable, as we can add as many nodes as possible. But in case of the RDBMS, we have to, it is non-linearly scalable, as because sometimes we are trying to upgrade the hardware, then we are going to work with the optimization of the queries, updating on the indexing techniques, and so many other things that we work on. We go for the normalization. So when we go for the normalization, again the size of the data is increased, and again that we have to handle those problems. Then in the Hadoop, we go for the batch processing, and there is less of interaction. But in case of RDBMS, it is more of interactive as well as the batch processing we can do. Hadoop is meant for handling the petabytes of data, and RDBMS can handle the gigabytes of data. Hadoop is based on write once and read many times. That means when you are going to create some kind of applications, so you have to understand that you use Hadoop only when you have such kind of activity in that. So where you are going to write, that means read more kind of operations, that reading operations are more and writing operations are less. And in case of RDBMS, read write many times that you have been working with, but the RDBMS has its own limitations, which can be for the purpose which can be used. And for that, you can say, in order, if we have read write many times of problems, then we go for the cloud databases, like we have MongoDB, Cassandra, and so many other NoSQL databases. And these days we have also the new SQL databases. So you can say they are the upgradation of the RDBMS. I think the time is over. So the rest part we will be covering in the next class, that is tomorrow.